Hi everyone, welcome to my channel. So in this particular video, we are going to discuss about activation function. So yes, let's see what is activation function. So I have drawn a simple neural network. So it has two input and one hidden layer. You can say this is a hidden layer. So yes, we are giving input to that particular hidden layer with adding some weight to it. Okay, so this is one input. This is one input and we're giving particular output of that particular input channel to this hidden layer. So let's see what is the input value that is going to our hidden layer, and in that particular hidden layer we have activation function. So let's see what is the input that is going to our activation function, which is in our hidden layer itself. So this actually, suppose I'm taking two inputs, so x1 x2, and with respect to x1 we have w1 weight, and with uh, x2 we have some weightage w2. So we actually do the multiplicative summation of both the inputs. uh, Here I have written as multiplicative summation of these two, so x1 w1 plus x2 w2, and with some addition of bias and that particular input. So this will be the whole input that is going to our activation function. So what actually it is taking, so takes the output from the previous cell. So previous cell is nothing but our in here actually I have input cell, but there is more interconnected neural network, very much complex neural network is there. So you can say it takes the output from the previous layer. So this is the output coming from the previous layer. The multiplicative summation of input and weight plus bias, this is the input going to this particular activation function and converts it into some form. So this input which is coming to the activation function, so basically what it does, this particular activation function converts it to some form, and that particular a form or that particular value actually taken input. So whatever the value this acquisition function gives, that actually goes to input, like goes as an input to our other neurons. So actually um, I have not drawn any other network connected. So yes, you can see if any other neurons would be here, then this particular output uh, will be going as a input to that particular neuron. So this is how actually this is how activation function established in a particular hidden layer. So yes, so let's see why activation function actually needed. So let's discuss about that. So activation function actually need, like, we use in the particular network because in deep learning actually we have to work with image recognition, or we can have as much as complex data set, like in machine learning we use. So to learn the complex pattern we need to have some activation functions. So let's go a little bit deeper into that. So actually what it does, uh, so whatever the input that we are giving, actually that particular input is not going to the the next neuron. It first, that particular input goes to the activation function, then whatever output from the activation function, that particular output actually is going to the next neuron or next layer, you can say. So that particular activation function actually responsible to whether to stop or whether to fire that particular uh, other, like that particular neuron or not. So basically what it is doing, so in the end, what is to be fired, like what value should be needed as per the requirement, actually it is decided by the particular activation function. This neuron is likely to be get fired or not, so it will be decided by the activation function. And one more advantage of using activation function, that it help in keeping value to the output from the neuron restricted to a certain limit as per the requirement. Okay, so why it is showing a certain limit? Suppose as we are giving this input, suppose here actually we are taking two inputs. There will be some condition we can take multiple inputs, right? So when these particular inputs are going to multiplied with these particular weights, so it it is possible it would be the large. This summation would be the very much large value, and also we are adding bias as well, so this turns out to be a huge number, you can say. It is possible. So to restrict this particular value, actually like in the end, whatever like what we are actually doing in the end, actually we are passing this input to our activation function. So so whenever these big values are going to the activation function, so what it is doing actually, it tries to rectify, not rectify, sorry. So it tries to restrict this particular large amount of value to a certain limit. Suppose there is a range, like there is a different activation function is there that I'm going to discuss in future videos. So there is various activation function which are certain certain range. Suppose we are using sigmoid function. Sigmoid function is range between 0 to 0 to 1, right? So it actually whatever value goes to the particular sigmoid function, it gives you the output in between this range. So actually this helps us to maintain a certain limit as per our neural requirement, because if only these two input are giving this much value, suppose if are using various parameters, so it is possible we can have various or much larger values, right? So this helps us to restrict the values in certain range. Okay. uh, and uh, and one more advantage. So yes, this is the most what to say, this is most useful advantage of activation functions. So actually what it does, it provides a non-linearity to the neural network. Okay, so what it basically means, so when we are giving this particular input, so you can say this is a linear function, right? Y is equal to mx plus c. Y is equal to mx plus c, right? I'm not able to write this properly, so you can guess it. So this is a linear function. So whatever the input is coming, input into some weight plus bias, it is similar to the linear function. So this is the input, and you can say this is the coefficient value, and this is the intercept value, or you can say bias. So this is a linear function. So if the data is more critical and the data is the more non-linear, so just simple if we do pass the linear values, so the model will not learn properly, right? So we need to understand the non-linear relationship in between the data set. So yes, this actually activation functions are actually helps us to convert these things, convert these linear values that we are giving. This is the linear value, right? So this particular linear value we are giving to the activation function, which converts it to the non-linear values, so that we have some improved model in the neural network. Okay, so this is all about activation function and why we need actually activation function in the neural network. Okay, one more question actually comes out here. Why we use bias here? Without bias also it will work. So why we need bias here? We just simply, we can do what, we can simply just multiply weight to our input and pass it to the hidden layer. So why you are giving this bias term? So bias actually helps the model best, like to fit the best to given data, and you can say to what to say to segregate between a nonlinear pattern in the data set. I can give you an example. So this is basically the linear function that y is equal to mx. So I have not added the intercept here, or you can say bias. So bias is 0. So actually basically it is passing through the origin. So if we do not take any bias term, the line always passes through the origin. It doesn't, like suppose we have some data, we have some data points would be there like this, like this, like this. uh, if the line always passes through the origin, it is not possible to get a good what to say, it is not possible to get uh, good pattern. It is not possible to find great pattern in our data set. So the line should be much more flexible. It can passes through like that, it can passes through like that to segregate the pattern between the data set, right? So actually we need some bias to add some shift to the line. Here actually in machine learning you can say in linear regression it is line, but in deep learning you can say to shift the activation function. Suppose you can say what I'm trying to say. Suppose if you do not take bias in the sigmoid function, or you are not taking bias in the input and giving to that particular input to the sigmoid function. So this is basically the graph of a sigmoid function. So if you do not pass, it will just try to converge in the if you take, if you do not, the point will be same. What I'm trying to say, this point, this point will be same, all the sigmoid function will pass through that. But if we um, add bias, we can shift the sigmoid function, right? So we can have what to say, we can have a great pattern to find um, the desirable output with the particular input given. So this is all about activation function, guys. So thanks a lot for watching. So if you have any doubts, so comment me out, so I'll try to solve your queries. Thanks.